We're in section 5.4. 5.4 is like the other sections we've been through, except in this section we have more than one variable. So we'll be adding, subtracting, multiplying, performing function things where we have more than one variable. So in this problem, I ask you to evaluate 4x squared y plus x cubed y squared plus 8x minus 5 when x is negative 2 and y is 4. So if I take the variables out, I have 4x squared y plus x cubed y squared plus 8x minus 5. I'm going to plug in x to be negative 2. So x is negative 2, so I'll put in negative 2 wherever x's were. Y is 4, so I'm going to put a 4 everywhere I saw a y. Now all of my parentheses are filled in. Remember, exponents come before multiplying and before adding and subtracting, so we're going to deal with exponents first. So in my first term, I see 4 times negative 2 squared times 4. So that would be 4 times 4 times 4. In my next term, I have negative 2 to the third. So that's negative 2 times negative 2 times negative 2, which is negative 8, and 4 squared is 16. Okay, I just rewrote my other terms. So all my exponents are done, and so now it's time to multiply. So 4 times 4 is 16. So this would be 16 times 4. So 16 times 4 would make this term a 64. In my next term, I have 16 times a negative 8, so I know my sign is going to be negative, and 16 times 8 is 128. So that's a negative 128. 8 times negative 2 would give me a negative 16, and then I have the negative 5. It doesn't matter how you group them. I'm just going to group the first two and the last two. So if I group the first two, 64 minus 128, those have different signs, so I subtract and take the sign of the larger, which would be a negative 64. Looking at my second two terms, they have the same sign. The same sign tells you to add and keep the sign, so this would give me a negative 21. Now then, my two terms have the same sign, so I add and keep the sign, and that would be a negative 85. So that's my answer. The degree of a polynomial with more than one variable is the largest sum of the exponents of the variables in the term. This is one of those definitions that's easier to see in work, in a problem, than it is easier to deal with through the textbook. So I ask you to fill in the blanks for 8x to the fourth, y to the fifth, minus 7x cubed y squared, minus x squared y, minus 5x plus 11. So here's what that definition that I spoke of earlier meant. In my first term, 8x to the fourth, y to the fifth, if I sum up my exponents, I get the number 9. So that's the degree of that term. My next term is 7x cubed y squared, so 3 plus 2 would give me a degree of 5. My next term is x squared y, so there are two x's and one y, so that would give me degree 3. My next term is 5x, so there's one x. And my next term is a constant 11, which means it has no variables, and so its degree would be 0. The largest sum that you see is the 9, and so that is the degree of the whole polynomial. The leading coefficient is just the number in front. So the number in front in this problem is 8. And the constant is the term without a variable. So the term without a variable would just be 11 there. And that's how those short answer questions would work. Your next problem asks you to simplify, and it's just a regular addition problem. It just has x's and y's. So you have negative 8x squared y minus 3xy plus 6. And with that, you're going to add 10x squared y plus 5xy minus 10. I prefer to stack them. So I'm going to take my second polynomial and stack it under like terms. So I'd have a 10x squared y in the first column plus 5xy in the second column minus 10. When I add those up, 10 minus 8 would give me 2 of those. Just keep the variable term, which would be x squared y. 5 minus 3 would be 2 of those. Just keep the variable term, which would be xy. And a negative 10 plus 6, they have different signs, so I subtract and take the sign of the larger, and that would be a negative 4. 2x squared y plus 2xy minus 4 would be your answer. Okay, let's try one more of those. In this problem, you see that it's a minus, so your problem is 7x cubed minus 10x squared y plus 2xy squared minus 5. And from that, you're subtracting 4x cubed minus 12x squared y minus 3xy squared plus 5. Remember with this one, the first thing that you need to do is rewrite it. We're going to take this negative and change every sign in the second set of parentheses. So this would be a negative 4x cubed plus 12x squared y plus 3xy squared minus 5. Okay, so my first polynomial was 7x cubed minus 10x squared y plus 2xy squared minus 5. And I'm going to take my new second polynomial and stack it underneath that one. So that's a negative 4x cubed, a positive 12x squared y, a positive 3xy squared minus 5. Now I took care of all my signs there, so all I have to do is add up what's left. So 7 minus 4 would give me 3 of those. That would be 3x cubed. 12 minus 10 would be 2 of those, 2x squared y's, plus the 5xy squared. And on the end, they don't cancel out. They have the same sign, so I'm going to add and keep the sign. So my final answer is 3x cubed plus 2x squared y plus 5xy squared minus 10.